Today is going to be our last note for our review section before we move into the new material for the course. So this one's going to be about right angles using Pythagorean theorem and sohcahtoa to find the missing sides and angles. So I will recommend that you have your calculator out and do the calculations along the way with me to make sure, because every calculator is different, so what I'm inputting into my calculator might not work for yours, and if we run into an issue, then we'll have to figure out what is the proper order for your specific calculator. Okay, so first talking about Pythagorean theorem, that is a squared plus b squared equals c squared. So again, this is when we have a right angle triangle. The C is the hypotenuse, which is your longest side. And C is also the side that's across from the 90 degrees. So across from the 90 degrees is C. And this one we have just the triangle facing a different direction, but we still have the 90 degrees that we're going to go across from to get side C. Okay, so that is the important one to label. The hypotenuse, the longest side, always has to be C. Okay, now your other sides are going to be A and B. These sides don't matter as much which one you label A, which one you label B. It's just that hypotenuse that needs to be C. So we can label these as A and B, and over here we can label A, B. Okay, if you were to label it opposite, if you were to put B here and A here, perfectly fine as well. You'll get the right answer. Okay, so solve for the unknown side. So looking here, we know two sides of the right angle triangle. We do not know this third side. So we want to determine what that third side is. We want to label our A, B, and C. So the A squared plus B squared equals C squared. Across from our 90 is our hypotenuse, which is our C value. And our other two we can label A and B. Okay, so we're solving for our hypotenuse. So using the Pythagorean theorem, A squared plus B squared equals C squared. Our A we labeled as 4 centimeters, so we're going to put 4 squared. Our B is 6, so we'll put 6 squared. And our C is x squared. So what we're going to be solving for is x. So we have 4 squared, which is 16, plus 6 squared, which is 36, equals x squared. And 36 plus 16 is 52. So 52 equals x squared. Now, we still don't have x by itself. We need to get rid of this squared in order to have x by itself and find that missing side. So we need to do the opposite to bring the squared to the other side. The opposite of a squared is a square root. So the square root of 52 is equal to x. And we get 7.21 centimeters as our answer. Okay, looking at the second example here, we have a triangle. We know two sides. We need to find the third side. Labeling our sides across from the 90 degree is where our hypotenuse C is. And we can label our other sides as A and B. So again, Pythagorean theorem, A squared plus B squared equals C squared. Our A we have as 10 meters, so 10 squared. Our B is x, so x squared. And our C is 13, so 13 squared. So 10 squared is equal to 100 plus x squared equals, and 13 squared is 169. Now we want to get x by itself, so the first thing we want to move is the 100 to the other side. When it gets moved to the other side, it's going to become a subtract. So we'll have x squared equals 169 minus 100. Our x squared is equal to 69. And getting x by itself, again, moving a square to the other side becomes a square root. So we want the square root of 69. And we get an answer of 8.31 meters. Okay, so when we're given the hypotenuse and we don't have another side, we just have to do an extra step, and that's rearranging the equation in order to find what that side is. Now, if we are looking at the angles in a triangle, our angles in a triangle add up to 180 degrees. So if we look at the first example here, we have a right angle triangle. We know that the one angle is 45. We know this angle, it doesn't exactly tell us, but that square there is telling us that that is 90 degrees. So knowing two angles, we can find out this third angle because we know that the angles have to add to 180. So knowing that it adds to 180, we can start with that amount, and we can subtract the two angles that we know from that total amount. So 180 subtract 90 subtract 45. And that will give us 45 degrees. So our angle X is 45. The next example here, we have a triangle. We know two of the angles and we want to find the third. Again, we know it adds to 180 degrees. So our angle X is going to be that 180 degrees, subtract the other two angles in the triangle. So subtract 120, subtract 36. So 180, subtract 120, subtract 36. We're left with 24 degrees. Okay, so now we can look at having our right angle triangles, and when angles are involved, we are going to be using sohcahtoa. Okay, so that means this first part here, that is sine of an angle is equal to the opposite side over the hypotenuse. This second part here is using cosine. So cos theta is equal to the adjacent side over the hypotenuse. And the third one is tan. So tan theta is equal to the opposite side over the adjacent side. Okay, so I want to start by labeling this triangle here. If we have this as our angle, this is our theta here. In relation to this angle, our hypotenuse is here. Across from the angle is the opposite side, so this is our opposite. And the side that is directly in relation to the angle right beside it is the adjacent side. So we are given all three sides, the measurements of those in the triangle. So we could set up our different ratios that we have. So for sine, we said it's opposite over hypotenuse. So the opposite side we've labeled here, and it's 8. Our hypotenuse we've labeled, and it's 17. Looking at the cosine ratio, it's adjacent over hypotenuse. We've labeled our adjacent here, it's 15, and we've labeled our hypotenuse as 17. So that's going to be 15 over 17. And our last one, tan is opposite over adjacent. So again, we've labeled our opposite as 8, our adjacent as 15. So that gives us the ratio here, 8 over 15. Now, in order for us to find the missing angle, we have our ratios set up, but we actually need to get theta by itself. So if we look at sine theta equals 8 over 17, to get theta by itself, we need to move sine to the other side. When we move sine to the other side, it becomes a sine inverse. So we're going to have theta is equal to sine inverse, or we put a -1, and in the bracket we keep that ratio that we have. So now when you go to put this in your calculator, on mine I would put 8 divided by 17, press equals, and then I'm going to hit my second button. You could also have a shift button on your calculator. When I hit second, then the sign -1 will come up, and you can click that, and that will give you the degree answer. And we get 28 degrees. Okay. So I'll show you that for the other two ratios as well. But since we're still solving for this theta, we should be getting 28 degrees every single time we calculate it. It's just that there's different ways to find the answer. So the next one is the cos theta equal to 15 over 17. Same thing applies. We want to get theta by itself, so we need to move cos to the other side. Moving cos to the other side, it will be a cos inverse, and we write that as cos -1, and the 15 over 17. So again, in my calculator, I'm going to put 15 divided by 17 equals. I'm going to press second, and this time I'm going to hit cos -1. And like I said before, we should still get that 28 degrees. Okay, I recommend putting all of these in your calculator just so you know the proper process to get the right answer. The other thing we need to make sure is that our calculator is in degrees and not radians. So if your calculator is telling you, if it has an RAD somewhere, then we do not want that. We need to change it and make sure that we are in degrees. Okay, again, if you're not sure how your specific calculator works, ask me and we will go through the process together. The last one I'll show you is tan. So tan theta equals 8 over 15. We want to solve for theta, so we need to move tan to the other side. It'll be a tan inverse. In my calculator, I'm putting 8 divided by 15 equals. I'm pressing second and my tan inverse, and the theta will be 28 degrees. Okay. Depending on what information you are given in the question, generally you're only going to be given 2 of the sides. You need to label those, determine if you have opposite, adjacent, or hypotenuse, and going from there, you're going to decide if you're going to use sine, cosine, or tan. Okay, so we can also use sohcahtoa to find a missing side as well as the missing angle. Taking a look at the first question here, we have an angle of 29. We have a hypotenuse going across from the 90 degree of 8, and we need to know what x is. So labeling, we have a hypotenuse here, we have theta, and across from the angle, that's the side we want to find. Across from the angle is the opposite side. So when we're dealing with opposite and hypotenuse, if we look up here, opposite and hypotenuse goes with sine. So we have sine theta equal to opposite over hypotenuse. Now that we have the proper ratio set up, we can fill in what we know. So we know that theta, our angle, is 29 degrees. Our opposite we need to find, which is x, and our hypotenuse is 8. Now what we need to do here is get x by itself, which means we need to move this divided by 8 to the other side. We do the opposite of dividing, we bring it over, it will be multiplied by 8. So 8 times sine 29 equals x. Now, when I put this in my calculator, I'm going to press the angle first. I'm going to press 29, and then I'm going to press sine. So that takes care of this piece. And then we just need to do this part here, which means we multiply by 8. Okay, so again, I put 29 sine times 8. Okay, so you can try it in your calculator. I get an answer of 3.88 as the length of my opposite side. So again, try that out on your own calculator. You might have to input it differently than I do. If you have troubles with it, please let me know. Okay, Now, looking at this next example, we are given two different sides, an angle, and we want to know what this missing side is. Now, if we have a right angle triangle and we have two of the sides, we could use Pythagorean theorem to find this third side, but I'm going to show you two different solutions using sohcahtoa to find A, since we have this angle here too. So if I label my sides, across from the 90 degree is the hypotenuse. Across from the given angle will be the opposite side. And directly beside the given angle is the adjacent. Okay. So we can solve this two different ways. When we use our two different trig ratios, we're still going to end up with the same answer for A. If we don't, then we did something wrong. So looking at the first one, I'm going to use, let me change colors here. We need to use our angle theta. The first one, I'm going to use the opposite side and find the adjacent. So if I have opposite and adjacent, if we look at sohcahtoa, that means we need to be using tan. So tan theta equals opposite over adjacent. Filling in what you know, tan, our theta, our angle is 55. Our opposite is 12 over our adjacent A, which we don't know, we need to find. Okay, so I want to rearrange my equation here to get A by itself. That means we're going to have to move the divide by A over to this side. It'll become multiply. So A tan 55 equals 12. And now I need to move the tan 55 over here. Since we are multiplying here, when we bring it to the other side, it will be divide. We'll have A equals 12 divided by tan 55. Putting that in my calculator, I'm putting 12 divided by, I have to put my angle first, so I'm going to put 55, and then I'll press tan, and then I'll press equals. So I get an answer of 8.4. Okay, so that is the length of side A. So now I'm going to show you a different way to find the answer for A, and that's using the hypotenuse instead. So we have our hypotenuse, we are needing to find the adjacent, and we still have our angle theta. So if I am using adjacent and hypotenuse, if I look at sohcahtoa, I now want to use the cosine ratio. So cos theta is equal to adjacent over hypotenuse. Fill in your values that you know. Cosine of the angle 55 equals the adjacent, we do not know, it is A, and hypotenuse is 15. Okay, so we need to get A by itself, which means we're going to move the divide by 15 to the other side. The opposite of divide is multiply, so we're going to have 15 times cos 55 equal to A. In my calculator, I'm putting 55 cos times 15 and I get an answer of 8.6. Okay, so we're slightly off by a couple decimal points, but we see that we're around the same length there for our adjacent side. Okay, so if you have any problems with your calculations here, again, let me know. Otherwise, you are able to work on the worksheets that are provided to you.